Hello there, Algebra students. This is Mr. Kashi speaking. This is our second video on 10.1, exploring quadratic graphs. And what we're going to do is, so last time we graphed the parent function of y equals x squared, and now we're going to be doing some translations of that, or transformations of that. So we're going to be doing graphing parabolas that are very, very close to the parent function, but hopefully you can see how the graphs change with the different equations. So this next equation that we're going to graph is y equals negative x squared. I want you to remember that that negative out front is like having a negative 1 out front of that x squared. So we're going to fill this table with the points, and then we're going to graph those points on the grid to the right. Whenever we just have one term like this, we want to make sure that we use the x's that are right around the y-axis. So we're going to go from -2 and -1, which is 2 points before the y-axis, and 0 is on the y-axis, 1 and 2, that's after the y-axis. So we're going to plug these in. Now there's going to be a lot of negatives here. So we have the negative for the x squared, but we're also having the negative for the -2 that we're plugging in. So we would say this is -2 squared, which is a positive 4, but then that negative out front makes it a -4. Same thing for the -1. We'll be plugging that in. For x, -1 squared is 1, but we have that negative out front, which makes this a -1. Plugging 0 in is a little bit easier because 0 squared is 0, and you don't really have a positive or -0. That's going to end up being 0. And then we have, we're plugging in 1. 1 squared is still 1, but we have that negative out front. So we have a -1 for our y. And we plug in 2. 2 squared is 4, and then that negative out front makes it a -4. So I do want to draw your attention to these numbers right here and see how that they get mirrored or reflected down like that. We're going to be talking about how that is symmetrical and how parabolas are always symmetrical. So what we're going to do is we're going to plot these points. Okay, so we just have our x's and we have our y's, which are ordered pairs. Okay, so technically this would be just the point -2, -4. Okay, bringing this right there and this right there. Okay, and so we have all these points. We have 5 points that we're going to plot, and that'll be giving us our shape of our parabola. So here we have -2, -4, which is right there. -1, -1, 0, 0. Then we have 1, -1, and we have 2, -4, like that. Then we can create our parabola. It should look something like this. Okay, and hopefully you can remember the parabola that we had before. We had this parent function that looked like this, right? Y equals x squared is the parent function. And really all that happened is we took each of these points and we just flipped them down over the x-axis. So you can hopefully see how these points just everything got flipped. So instead of above the x-axis, now it's down below the x-axis. The next thing that we're doing on this slide is we're going to make a table for y equals -2 x squared. So we're going to put this -2 x squared in the middle, right? And we're going to be using those same points, -2, -1, 0, 1, and 2. Those x values that we use will change with different when our equations get a little bit longer, but as of right now, we're just using these 5 here. So making sure that we're plugging in, making sure that our negatives are all accounted for. So -2 squared would be 4. 4 times -2, this would be a -8. And then we have -2 out front again, just as the equation says, but we're plugging in a -1 for x. So -1 squared would be 1 times -2, that would be a -2. A little bit easier when we plug in 0, because 0 squared is just 0. 0 times anything is 0. then here we have negative 2. We're going to have 1 squared. 1 squared is 1 times negative 2. And here we have negative 2. We're going to plug in a positive 2. 2 squared is 4 times negative 2 is negative 8. So once again, hopefully you guys see how these are the same and those are the same. And we're going to plot those points on the same grid above. I'm going to do it in a different color so you can kind of see the difference here. So we have negative 2, negative 8. So we'll have a point there. We have negative 1, negative 2. 0, 0, so we have another point at the origin. We have 1, negative 2, and then 2, negative 8. So our parabola would look like this. Okay, and you can see how it has a little bit different shape. Some students say, oh, well, it looks skinnier. What we say is this parabola stretched vertically. If you want to get very specific, you'd say by a factor of negative 2. So we took our first one, we flipped it because it was a negative 1 on front, but now we have this negative 2 out front. We're actually stretching it. It looks taller. And it would get even taller if we put a negative 3 in front, or a negative 4, or negative 5, negative 6. The more it would stretch vertically. Okay, and we'll go through a couple of the other situations here as we go through this chapter. So the next problem that we're going to be doing is we're going to be graphing 2x squared. Hopefully you can see how close it is to the last problem that we did. Instead of having a negative 2, we have a positive 2. So I'm going to this 2x squared here. We're going to plug in these same values. All right, and so we have a 2 out front. We got negative 2 squared. Well, negative 2 squared is 4. 4 times 2 is 8. We have a 2 out front. Negative 1 squared is 1 times 2 is 2. 0 squared is 0 times, well, 0 times anything is 0. And we have 2 times 1 squared. 1 squared is 1 times 2 is 2. And then we plug in a positive 2. 2 squared is 4 times 2 is 8. Once again, we have those symmetrical. Obviously, that was a little fast. If you need to pause to make sure you get those notes down, that's just fine. Then we're going to plot those points. We have negative 2, 8. And we have negative 1, 2, 0, 0, 1, 2, 2, 8. So once again, compared to our parent function, it's stretched quite a bit. It's stretched by a factor of 2. So you might say it got twice as tall from what we had from our parent function. So here it's a little bit skinnier, it's a little taller. What we say, it's stretched vertically. Stretched vertically. Okay, and if you wanted to get real fancy, it would be by a factor of 2 because the 2 is out front. All right. Now what I want to do is I want to take a look at something a little bit different. We're going to have a 0.5 or 1/2 out front. And this is where these numbers are going to get a little bit tricky. Which ones we're going to plug in at least. So if you can still put 0.5 x squared here, but thinking ahead, we're still going to put 0 here, but remember we're going to have half of what we have there. So if we plug a 1 in, 1 squared would be 1, and then you're taking a half of that, which you can, but plotting half of points on a grid is a little bit tricky. So now what we want to do is we want to be plugging in things that we know that we can take half of. So what I would do is I would plug in probably a negative 4, a negative 2, 0, 2, and 4, just to kind of give us a bigger range of what we can do here. So you'll see why I did this once we plot them on on the grid. So we're going to plug in -4. So we have -4 squared. Well, -4 squared is 16. But 16 times 0.5, or half of 16, that's going to be 8. And here we have -2, so we have 0.5 times -2. -2 squared is 4. Half of 4 is 2. Here, once we plug in a 0, well, 0 squared is 0. 0 times anything is 0. And then hopefully you'll see how these are going to be matched up again. So we have 0.5 times 2 squared. Well, 2 squared is 4. Half of 4 is 2. And then 0.5 times 4 squared. 4 squared is 16. Half of 16 is 8. So now we have our points here. And so I'm going to plot those on our grid up here. We have -4, 8. And we have -2, 2, 0, 0. Then we have 2, 2. And then we have 4, 8. And now you can see how this is a little bit wider. Not only wider than our graph, but wider than our parent function of y equals x squared. And so now we have a name for this. Okay, we would say that this shrunk. We didn't stretch. We shrunk by a factor of 0.5. We took it. Now it's half as tall as our parent function. Okay, so if you were to get technical about it, really, if we went up 1, this would be 1/2 right there, if you wanted to think of it like that. So these are this is 2 graphs, one that got stretched by a factor of 2, and one that shrunk by a factor of 1/2. And this is what we're going to be practicing on stretching and shrinking graphs that have a vertex here through the origin.